I started work on a new machine. I made a base. I made 2 arms connected to the base. 4 more arms to go. I was putting together parts to make the other arms. Everything was going great, and then my CNC's spindle motor broke. Because it felt like I pushed my old CNC spindle right up to the limit, and because I wasn't able to find any strong spindle motors that would fit my old CNC machine, I decided it's time for a CNC upgrade. So here we are, upgrade time. This is what I got, a Lunyee 3018 Pro Ultra, offered from Lunyee in exchange for making this review video. So let me be very transparent. Did I get this thing for free? Yes. Does that mean I cannot say whatever I want about it? No. In all fairness though, this machine seems like the perfect replacement. It has a bigger work area. With my old CNC, I could only mill pieces smaller than 12 centimeters. With this one, I am now able to mill pieces up to 30 centimeters. It also comes with a 500 watt spindle motor. This is quite a lot compared to my old CNC's 100 watt spindle. With this motor, I should be able to use both a higher step down and feed rate setting. So basically, I should be able to mill aluminum pieces much faster. We will check how this pans out when running some tests later in this video. But first, we need to put it together. So we finished assembling the machine. Next, we want to start it up. However, it's a good idea to check the wiring one last time. In my case, I connected this cable to the wrong socket. So let's fix it. Let's also connect some other things, the probe, which will help us later in this video, and the controller, which we will use right away to test all the motors. So here we go, we are ready. Let's turn it on. The controller shows something. We select Move from the menu, and as you can see, all the motors are working. So now we are ready for some tests. To do the tests, we need to first clamp down our aluminum workpiece. We could use the clamps that came with the machine, like this, or we could use our own clamps. I went for option B, because with shallow clamps, the risk of having your end mill collide with the clamps is much lower, and that's why I prefer them. Next, the probe. We use this probe to let the machine know where the surface of our workpiece starts. So now let me just straight up tell you what I did and why I did it. First, I wanted to make sure everything is working as it should. Therefore, I went for a very conservative setting. So basically, with this milling job, the machine is going slow and steady. How slow? Well, I'm only showing you a few short clips, but this milling job actually took 5 hours to complete. You see how two of the parts aren't connected to the plate anymore at all? That should never happen. It was the first time I used that probe and I did it slightly wrong. I was very pleased with the first test results. And I was wondering, how much faster can I go now that I have a 5 times stronger CNC machine? A reasonable starting point would have been, well, 5 times faster. However, in a flash of mad scientist delusion, I decided to run the machine on a 10 times faster milling setting. So here we are, test number 2, 10 times faster milling. The end mill didn't break. This came as a surprise to me. I expected it to break, to be honest. This test was about pushing the machine to its limits, but it just chugged through the aluminum and finished the job. A closer look at the pieces reveals that we really did push the machine a bit too hard. The slow and steady piece was perfectly machined with a tolerance of less than 0.1 millimeters. On the other hand, the mad scientist piece looks a bit rougher and the dimensions aren't quite on point anymore. I did some more investigating and test milling and here is what I found out. When you push this machine really hard, one of the lead screw nuts might move a little bit. This happened to me with the second mad scientist test. So whenever you notice that the milling isn't as precise as it used to be, check and readjust all of your lead screw nuts. There are 2 nuts on each lead screw and they need to be adjusted in such a way that there is minimal play along the lead screw. So I readjusted all of the lead screw nuts and now we are back to precision milling. No more reckless speed settings though. After this I wanted to do one more final test with reasonably fast milling settings. However, there was one thing I wanted to do before starting that test. I work in the same room as my CNC mill, so to reduce the noise I made a box. I put my CNC machine inside the box. I closed the box. Much better. Then I opened the box again. We need to set up our next milling job here. So here we go, reasonably fast milling test. At this point you might wonder, you're making all these parts, but how do you get them out of the aluminum plate? Well, thanks for asking. In my case the answer is with a knife. Now we got the part out of the plate, but as you can see, there's still a lot of aluminum around the part we want to get rid of. So let's do that. I made 4 parts of this type, and what can I say? The dimensions are all on point and the finish on the sides is nice. So that's it for today. I will continue making parts with my new Lunyee 3018 Pro Ultra. Here are my favorite things about this machine. First and foremost, the spindle motor. Just look at it spin, no vibrations whatsoever. Second, the big work area. Having used the tiny desktop CNC for years, the work area on this one feels gigantic. Lastly, the rigidity of the machine is solid, enabling us to produce precise parts. So that's that. Thanks for watching. See you next time.